Hello. In this video, we are going to discuss about the concept of continuous charge distribution. Now, first of all, let us try to understand what it means in simple terms. Suppose we have a system in which there are just two electrons. Obviously, we cannot neglect the single identity of each electron. We can easily differentiate between the two electrons, and hence we have to focus on their individual identities. However, what about a surface on which we have millions of such electrons? Do you think it would be possible to differentiate between the different electrons in a group of millions of electrons? Well, my dear students, it would become quite tough. Now, in such cases, when the charge involved is much greater than the charge on an electron, its quantum nature can be ignored and the charge is assumed to be distributed evenly and continuously all over the surface. This is known as continuous charge distribution. Now, before we proceed with different types of continuous charge distribution, I would just quickly like to tell you what the quantum nature which I used during the definition of continuous charge distribution mean. Quantum basically means the minimum amount of physical entity involved in an interaction. Here, that minimum amount is the charge on an electron. So, by neglecting the quantum nature, we mean that we can neglect the individual charges, rather we can take them to be a continuous charge. Instead of talking about an individual electron, we'll take the charge to be distributed continuously over the entire surface. Now, let us try to understand different types of charges. First of all, I want to tell you that there are basically three types of continuous charge distribution. First of all, I'll be talking about volume charge distribution. Then I'll talk about surface charge distribution. And as we say, last but not the least, we'll talk about line charge distribution. First of all, talking about volume charge distribution. Well, volume charge distribution is represented by the symbol rho. As the name itself suggests, volume charge distribution is a charge distribution spread over a three-dimensional volume or regime of space. For example, I have taken this piece of stone. Now, as I said, volume charge distribution is a charge distribution spread over three dimensions, and those three dimensions I have represented here. Yes, now I think it will be clear. Those three dimensions I've represented here as x-axis, y-axis and z-axis. So we have three dimensions. Number 1 x, number 2 y, number 3 z. So it is a three-dimensional regime or space. When the charge is spread over a three-dimensional volume or region of space, then we say it to be volume charge distribution. Hence, mathematically we can write volume charge distribution rho is equal to charge distributed per unit volume. So here we define volume charge distribution. Secondly, we move on to the surface charge distribution. Now, as we define volume charge distribution, we'll be defining surface charge distribution on the same pattern. It is a charge distribution spread over a two-dimensional surface. Here I have taken a surface which has two dimensions, length and breadth. So surface charge density at any point on a surface S is defined as the charge per unit surface, and it is represented by sigma. So sigma will be defined as charge distributed per unit area. This defines your surface charge density. It is represented by sigma and it is a two-dimensional distribution of charge. Now I'm sure you guys would be able to answer as to what number of dimensions would the line charge distribution have. Yes? I'll give you a 20-second break and I hope you'll be able to answer it by your own. Okay. Now, line charge distribution is represented by lambda. And yes, it is a charge distribution along one dimension. It can be a straight line. If I consider this straight line, so the charge distribution along one-dimensional curve or line in space is called line charge distribution. It is represented by lambda, and lambda, which is the line charge distribution at any point, is defined as the charge per unit length of the line at a particular point. So line charge distribution at some particular point P is defined as the distribution of charge per unit length of the line at that point P. So I hope you're clear with all the three types of charge distributions. The first one is volume charge distribution, the second one is surface charge distribution, and the third one is line charge distribution. Thank you, dear students.